Sedimentation basin in a water treatment plant is designed for a flow rate of 0.2 meter cube per second. The basin is rectangle with a length of 32 meters and width of 8 meters and depth of 4 meters. Assuming that the settling velocity of these particles is governed by Stokes' law, given density of particles is equal to 2.5 gram per centimeter cube, density of water is 1 gram per centimeter cube, and dynamic viscosity of water is equal to 0.01 gram per centimeter second. Gravitational acceleration is 980 centimeters per second square. If incoming water contains particles of diameter 25 micrometers, the removal efficiency of these particles is options are 78%, 51%, 100%, 65%. He said Stokes' law. So according to Stokes' law, Vs is equal to G into minus rho W into d square upon 18 mu. So everything is given in centimeters and second. Units are very much important in environmental engineering, so keep this in units. So this is 980 that is given to you, and rho s is given as 2.5, and this is minus 1, and this is d. D is given as diameter of the particles is given as 25 micrometers. 25 into 10 to the power of minus 6 meters, you can write as 10 to the power of minus 4 centimeters a square upon 18 multiplied with mu is given as 0.01. So once if you substitute all these things, you will get Vs as 0.051 centimeters per second. This is the settling velocity of this particle. 25 micrometer particle settling velocity is this one. And now we have to calculate overflow rate. Overflow rate. So how will you calculate overflow rate or surface overflow rate? Discharge upon surface area. What is discharge given to you? 0.2. Surface area is L into B. L is 32. B is 8 meters. If you take this, you will get it as 0.078 centimeters per second. This is what you will get overflow rate. That means a particle whose velocity is 0.078 centimeters per second, 100% of those particles will get settled. Now for this, if you see, the velocity is 0.051 only. That means the velocity is less than this velocity. That means 100% of these particles will not get settled. If you want to calculate the efficiency or efficiency of removal, is given as 0.051 upon 0.078 multiplied with 100. Approximately you will get it as 65.38%, and the only option available to you is 65%. So very simple application. Apply Stokes' law, calculate overflow rate, and efficiency is Vs upon V overflow rate, that is 65.38%, 65%. Thank you.